4 other adults in the room today. So we have Dave, of course. And then you guys know Haley and Josie. Do we decide last names?
Yeah.
Okay. Actually, it's Miss Nelson and Miss Jerpseth. Okay. And then this is Miss Iden, and I'm gonna let her introduce herself.
Hi everyone, I'm a senior math major at the College of St. Benedict, and I'm just going to be here to observe Miss Botton's class for this week and next week with you guys in your Friday mornings. So yeah, I'm happy to help if you have questions like during homework and everything. So
Sounds good. Thank you.
thank you.
I think we have to tell this hour to remind you of everything.
Maybe pump that response.
Maybe it goes from square.
Anything to help.
Yes. It's Friday, guys. Yay. Anyone have fun plans?
Oh, I'm doing tubing at Powder Ridge.
Oh, that sounds fun. Well, I could tell you a tubing at Powder Ridge story.
Yeah, tell us.
So, my son, Chase, my middle child, he's now 25, but back when he was like maybe 10, we took like a whole bunch of his friends tubing, and we took so many that we had to take a couple of other adults so that they would drive the kids. And so there was like me, my husband, my neighbor and his wife, and our daughter, and we linked our tubes together, and they even pushed us, so they, like the people that work there, and so they push us down, and my son Chase is like super smart, but kind of has his head in the clouds a little bit, you know, like he's kind of unaware of his surroundings sometimes. So he, at Powder Ridge, you know how you sit on like something in between the rows, and then there's one, and then there's another one? Well, we're 5 tubes coming down, and Chase steps out right in front of us, and we hit him, and he goes straight up in the air and lands down on his shoulder and his back. And I mean, he's like knocked out cold, right? So we go like end our thing, we run over to Chase, and we're trying, like, pretty soon everybody that works there is running down. Then the snowmobile comes from the, what do you call them?
Chalet?
Well, like the people, the rescuers or whatever. So they come. What's that? Ski Patrol. Yes, thank you. So anyway, finally Chase comes to, they put him on a sled, and they're taking him away, and then I'm going with him to the chalet or wherever, the med room. And so he's always been an athlete and loves sports, so as they're pulling him away, he's like this in his sled, you know? So then we get to the chalet, and they decide we have to take him to the ER. Now, this is like probably our 2nd time down, and he misses his whole birthday party. I have to take him to the ER, and he had like separated his shoulder, and then ever since then he has like a super bad back because of it. So don't step out in front of any tubers. All right? Okay. So we are going to go over 2 of the kinds of shortcuts for congruent triangles today, and then we're going to learn 1 or 2 new ones. I think we learned 2 new ones today. So first of all, we learned earlier this week about side, 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 and we talked about, to abbreviate that, is just SSS, and that one is pretty easy. Then we also talked about side, angle, side. And remember, for that one, the angle has to be in between the two sides. Okay, so if you notice here, that angle is right in between those two sides. This angle is right in between down here. The angle is right in between, and so on, okay? Then, if we look here, there is a new type, or a new step that we're gonna be adding to some of our proofs. So far, the proofs that we have done, the proof statement has always been like triangle ABC is congruent to triangle DEF, something like that. But sometimes what happens is instead of proving triangles are congruent, you can have to prove that angles are congruent or sides are congruent. When that happens, you still have to prove the triangles are congruent, but then you're gonna have an extra step where this is gonna be your last step. And the reason for that is CPCTC. Now, what that stands for is corresponding parts of congruent triangles are congruent. So here's what that means. If you had two triangles, and say this is A, B, C, and this is D, E, F. And let's say that they're congruent by side, angle, side. Side, angle, side. When those two are congruent, the other three things that are not labeled are also congruent. So you may do a proof and you get down to where triangle ABC is congruent to triangle DEF, and that is by side, angle, side. And then you're gonna have an extra step where maybe they want you to show that AC, segment AC, is congruent to segment DF. And what we write for that is CPCTC. It means anything left on this triangle that's not marked is also going to be congruent. And it can either be a set of sides or a set of angles. What that stands for, kids can have a hard time remembering the order of it or even the meaning. It's corresponding parts of congruent triangles are congruent. So I don't give much extra credit at all, but one thing that I will have you guys do if you're interested in 10 points extra credit is to come up with a school appropriate saying that starts with these letters. So I don't know why, but I always use this one. Chubby pigs can't talk Chinese. So it doesn't really have to make sense, but it's going to be a school appropriate saying that you come up with that you're going to put on poster paper, not poster paper, just computer paper. And I'll show you some that I have. So this one is, so first let me tell you how you get the 10 points. You have to have it school appropriate, okay? You have to have either a drawing or a computer graphic, okay? And it has to have color. So you do not have to be an artist to do this. I am not by any means an artist, so I'm lenient on that. But you have to have some kind of art on here, you have to have color, and you have to have a school appropriate saying. So this one is clever police can tame criminals. This is circus popcorn can taste crunchy. Confident penguins can't take criticism. Cheap pants cost 10 cents. So I have many, many that I've saved over the years. Calm people carry tranquil chickens. So if you ever wanna look through them, you can absolutely do that. I can get you plain paper. I have markers and I have colored pencils. And let's say that this is gonna be due next week, Friday, if you wanna do it. And again, I've been telling you guys, you have you have today, you have next week 5 days, and then you have 2 days that following week, and that's it. So if you don't like where your grade is right now, you need to be making up homework, and working hard right now, because you have a quiz next Wednesday, and then you're gonna have another quiz that Tuesday, the last day of class, okay? All right, I will tell you, I make this speech about school appropriate. So the year my son graduated, his group, one of his friends did, I have to think about this. Creepy pedophiles can't touch children or something like that. And I'm like, no, don't wanna hear about pedophiles, don't wanna hear anything about drinking or anything. So, school appropriate. All right, so we're gonna write a proof, okay? Just like we did yesterday, except they're gonna have an extra step. So when I go to do this, I'm gonna write MN is congruent to PN, and LM is congruent to LP. And like we talked about yesterday, if I have more than one given, I typically write them under step 1 and do 1 given, but you certainly could do 2 givens. Now, if you look here, both of the things that I just wrote are already up there, so they're already marked. Can you guys see something else? Reflexive, very good. So I can say NL is congruent to NL, or LN is congruent to LN. So I'm gonna say NL is congruent to NL, and that is reflexive what? Property, very good. Remember, you have your cheat sheet that gives you the reasons for them.
Would that be 3 lines on there?
Oh yeah, you're right, thank you. So yeah, every time you write it, another set of congruent sides, you want to add a dash to it. Now, are these triangles congruent?
Yep.
By
Side.
side. Now this is the thing that's a little bit harder. Yesterday, we just always copied this down and said side. Now today, they don't have that triangle, whatever is congruent to triangle, whatever. So we have to do that, okay? Dalton? What's up? Do you need to go to the nurse? Then you need to get your Okay, so if I look at this, I'm gonna say triangle LMN. And the reason I do it that way, I'm gonna go along the side that has 1 dash, and then the side that has 2 dashes, okay? So I'm gonna say triangle LMN is congruent to, right?
LPN.
What did you say?
LPN.
Yes, LPN, 1 dash, then 2 dashes. So LPN,
Is that side?
and that is side, very good, okay? Now the order that you write that in doesn't matter, but you just have to be consistent. And I just typically, if I have sides, I always go along 1 and then 2, and then 1 and then 2. Now, we have an extra step today, so we're just gonna copy that extra step down. Angle LNM is congruent to LNP. And these are angles, okay?
Is that new thing?
And this is the new thing. It's the chubby pigs can't talk Chinese. Okay, or whatever school appropriate saying you come up with. Alright, so now if we look at this one, we have congruent sides, and what do the arrows mean again?
They're alternate interior.
You look for alternate interior.
Parallel?
They're parallel. And notice they have the arrows here and they have the vertical lines here. Both of those represent parallel. So for step 1, I'm going to say RQ is parallel to TS and RQ is congruent to TS. Okay? And that's given. So, I have both of those things marked. Now, does anyone see something else that's congruent?
Reflexive.
Reflexive, very good. So that would be RT is congruent to RT. And like Maya said, that's reflexive property. Okay? Now, when you are given parallel lines, that means you have to do something with that. And Maya said it earlier, alternate interior angles. But make sure you pay attention to this. When you have a figure like this, where you have two triangles sharing a side, you have really two sets of, in this situation, you have two sets of alternate interior. You have these two, and you have these two. And what you have to decide is which set are congruent with these two lines parallel. What do you guys think? Would it be 1 and 2? 3 and 4. Do you guys remember me saying when you mark the congruent angles, you're gonna touch the side that is parallel. And then when I mark this one too, notice I'm touching the side that is parallel. Now, I'm gonna erase this and that 4 and that 3 and that 1, okay? So now what I'm gonna do is just label those angles. And for this one, I can either do angle QRT or TRQ. And then for the other one that I have marked, I can either say angle STR or RTS. Okay? Now, for what we have so far, we know two shortcut ways. We know side, 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 and we know side, angle, side. This one is side, angle, side. Very good. So that goes here. Now, oh, no, I'm lying, sorry. I skipped a step. What am I supposed to do instead? I'm not quite there yet. What kind of angles are these? They're, what kind? You said it before, when you have parallel lines, alternate interior. That's what I was supposed to write here. I went right to the triangles. So this is alternate interior angles theorem. Okay? Now we're at the point where we can say the triangles are congruent, and I was telling you yesterday we could steal it from right here, that congruent statement. Today we can't. So here's what I do. When I have two sides marked, again I go along the one with one side and then along the one with the two dashes. So I would call this triangle QRT. Is congruent to triangle. So then I'm going to go again along the side on here that has one dash and then 2 dashes. So I'm gonna call this triangle STR. Bless you. And again, Mayo is saying this is side, angle, side, so that is correct. So that's what I put here. Now, am I done?
No,
No.
you have to do the
I still have to do that extra step. So I'm gonna come down and I'm gonna say angle Q is congruent to angle S. And that is by what?
CPCTC.
Yep. So chubby pigs can't talk Chinese, or whatever school appropriate saying you come up with.
Are we doing this whole packet?
We are going to, yeah, we are actually. But the last part isn't proof, so I think you'll be fine. Okay, so we are gonna learn 2 new ways today. So we already know side, side, side. We already know side, angle, side, okay? Now, one of the new ones that we're gonna learn, one of the new ones that we're gonna learn today is called angle, side, angle, angle, side, angle. For this, it's really important that your side has to be in between the 2 angles. So just like we had side, angle, side, the angle had to be between the 2 sides. Here we have angle, side, angle. The side has to be between the 2 angles. So again, side is between 2 angles, okay? So, now this question, you've seen some like this already, but this is just asking us, can we use angle, side, angle?
Yes.
And it's yes or no.
Yes.
Yes, this is angle, side, angle, angle, side, angle. What do you guys think about this one?
No, because it's not in the middle.
Why?
It's not in the middle.
It's not in between. It's not in between. Very good. That side is not in between them. How about this one?
Yeah.
Mm-hmm.
Angle, side, angle.
Angle, side, angle. Very good. And then for D, what do you think?
Angle, side, angle.
Is it on both
No,
of them?
Not on both of them.
Correct. Isn't this one angle, side, angle?
But the other.
But this one, the side's not in the right spot. Okay. And then E, what do you think?
Angle, side, angle.
Yeah, and how do I know there's a
Reflection.
side? Reflexive. Very good, Dawson. So this is yes. Okay, because of that reflexive property. Okay? Now, the last one that we are going to learn is called angle, angle, side. Now, again, we have 2 angles and a side, but how this one is different, the side is not in between the 2 angles. So when the side is between the 2 angles, it's angle, side, angle. When the side is not in between the 2 angles, then we start at one of the angles and go angle, angle, side. So if the side's not in between, it's angle, angle, side. Okay? Here's another one, angle, angle, side. So if I go to this, now we have 4 different ways to show that 2 triangles are congruent. We have side, side, side. Whoops. We have side, angle, side. We have angle, side, angle, where the side is in between. And we have angle, angle, side. If it's not any of those, we write NP for not possible. So when they say explain your reasoning, they're just saying to name which one we're using, okay? Anything else I can mark on that?
Vertical angles.
Vertical angles, very good. Now, Notice we have two angles and a side. That tells me it's gonna be one of these two. Is the side in between the two angles? No, so which one would it be? If
Sorry.
angle, angle, side, very good. When the side's not in between, then it's angle, angle, side, very good. Okay, now let's look here. Is there something else I can mark?
Reflexive.
Reflexive.
It's not possible.
Yeah, is there anything else we can mark?
No.
There's no parallel lines, so we can't add those angles. There's no vertical angles. There's no right angle. So there's really, and we already did reflexive, so there's only two things, two sides. So we're just gonna do NP for not possible. Now, you see those arrows. What do you think of when you see arrows?
Parallel, alternate interior.
Alternate interior. Now, these two arrows say these two are parallel. What angles would be congruent then?
3 and 1.
Yes, 3 and 1. These have one arrow, so that means these two are parallel.
4 and 2.
4 and 2, correct. Okay, is there anything else congruent there?
Reflexive.
Very good. Is that one of them that we've learned?
Yeah.
Is it angle, angle, side, or angle, side, angle?
Angle, side, angle.
Angle, side, angle. Very good. The side is in between the two angles.
Vertical.
Vertical angles. Okay. You guys get this one would be angle, angle, angle. We have a side, side, side one. We do not have an angle, angle, angle one. And the reason is these two we're gonna learn in the second half. These are similar figures, not congruent. If you have a triangle that has 3 angles, you can go to a copy machine and you can blow that triangle up, or you can shrink it down, and it'll still have those 3 angles. So 3 angles does not determine that they are congruent. Angle, angle, angle does not work. And we'll talk more about that in a future chapter. Can I mark something on this one?
Reflexive.
And then this is 2 angles and a side. So which one is it?
Angle, side, angle.
Yep, the side is in between the 2 angles. Now last, again, remember we have the 4 or we have not possible. What can I mark here?
Reflexive, which would make it angle, side, angle.
Angle, side, angle. Very good. How about this one?
Angle, side, angle.
So do you know, see how
Oh wait, never mind.
the side's not in between?
Yeah.
So then it's,
Side.
so do you remember how you can do side, 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 side angle, side, angle, side, angle, or angle, angle, side?
Angle, side.
Yeah, it's 2 angles and then a side. The side's not in between, so it's angle, angle, side.
And the other one would be angle, side, angle.
And this one is angle, side, angle. Good. All right, so if you, oh, actually I made copies. For this whole chapter, I made copies because the proofs, I don't know if you have many proofs today. You have more? You only have 2 proofs. The rest of them are the kind that we went over at the end.
Just saying what we're doing.
Yeah.
Oh, so this was drawing.
How are you guys doing on this? Are you, is it hard, the proofs?
More difficult than what we were learning last time.
What do you think, Carson? But do you think it's hard?
It's harder than what we were doing before.
But you get it?
Yeah, that's how I feel
So if you finish early, guys, you can ask me for the printer paper and start working on that extra credit if you want to. You definitely don't have
I
to.
really don't wanna do